Isn't computer science all about computers? Well, let's put this into perspective. Saying computer science is all about computers is like saying being a doctor is all about stethoscopes. It just doesn't make sense. In this video, I will lay out to you three different yet important aspects of computer science and how they correlate into this one huge topic. But first, we must ask ourselves the question, what exactly is computer science? Well, computer science is the study of computing, as well as their theoretical and practical applications. Computer science applies the principles of mathematics, engineering, and logic to a lot of functions, including algorithm formulation, software and hardware development, and artificial intelligence. It is the future of humanity, which gets better and better with every day that passes. I'll now get into the three aspects of computer science that I will be talking about. These aspects are programming, networking, and physics. Let's get started. Ah, programming, the backbone of the very device that you are using right now. Programming is a very broad topic, though it is very easy to understand. Programming is the basis of every computer on the planet. When we write a program, we're giving the computer a set of instructions that look like a jumbled up form of English. You can think of programming like an obedient pet that will listen to whatever you tell it to do. In real terms though, programming is a process of creating a set of instructions that tell a computer how to perform a task. It can be done by using a variety of computer programming languages, such as JavaScript, Python, and C++. These programming languages can be compared to real-life languages such as Chinese, Spanish, or our very own language, English, because they each have their own set of rules that we must follow for the receiver, who can be computer or human, to understand what you are trying to say. These rules, however, are called the syntax of the programming language. Now, I have a question for you. Try to answer it in under 10 seconds. If you chose any one of those options, then you are indeed correct. Common examples of programming in everyday life are websites, app development, and games such as Call of Duty, Clash of Clans, and Fortnite. Seems amazing, right? Well, not entirely. Programming suffers from a lack of women in the workforce, otherwise known as gender stratification. Studies have related the phenomenon of a lack of women in the programming sector to a shortage of women role models. Characteristics of computer science students like geekiness and introspection, and also being riddled with misogyny that can be somewhat patronizing. In terms of sector retention, when women do study computer science and enter the ICT sector, they are twice as likely to leave than men due to work-family conflicts, the occupational culture of computing fields, and limited mentoring and networking opportunities, and for reasons such as lack of flexibility in contracts, expectations of excessive hours, and lack of recognition within their employers' organizations. Though, this shouldn't be an excuse to hate on the subject, as that is not the matter. In my personal opinion, it is one of the more intriguing topics which is in computer science, so do not let the cons draw you away from your goals. Next, we have networking, the backbone of computer communication. The reason why you can browse the internet, check social media, and how you are watching this video right now. Well, computer networking deals with stuff such as switches, routers, and access points that form the foundation of computer networks. Here are a few illustrative examples of networking. Switches connect and help to internally secure computers, printers, servers, and other devices to networks in homes or organizations. Access points are switches that connect devices to networks without the use of cables. However, since these devices are used in large organizations, it is bound for some errors to happen, which is why there are some protocols set in place to reduce error, such as a spanning tree protocol that prevents dangerous loops that can shut down an entire system. Routers connect networks to other networks and act as dispatchers. They analyze data to be sent across a network, choose the best routes for it, and send it on its way. Routers connect your home and business to the world and help protect information from outside security threats. While switches and routers differ in several ways, one key difference is how they identify end devices. A switch uniquely identifies a device by its burned-in MAC address. A layer 3 uniquely identifies a device's network connection by its network-assigned IP address. MAC and IP address uniquely define devices and network connections, respectively, in a network. A MAC address is a number assigned to a network interface card by a device manufacturer. An IP address is a number assigned to a network connection. Checkpoint question: where is all of this coming from? How are we able to use computers, play games, communicate, network, and all those other stuff? I mean, because of electricity, right? If you replied to the question saying electricity, then you were correct. But have you ever wondered how electricity works? This is where our physics aspect ties into all of this. Let me explain what physics is. Physics is a natural science based on experiments, measurements, mathematical analysis, with the purpose of finding quantitative physical laws for everything from the nanoworld of the microcosmos to the planets, solar systems, and galaxies that occupy the macrocosmos. Whoa, those were some big words. It basically means the study of everything and how everything works within the universe. Much simpler, right? The laws of nature can be used to predict the behavior of the world and all kinds of machinery. Many of the everyday technological inventions that we take for granted resulted from discoveries in physics. The basic laws in physics are universal, but physics in our time is such a vast field that many subfields are almost regarded as separate sciences. Moving back into electricity, one thing to note is that it is very important to our society. Without the existence of electricity, we would essentially be living in a stone world. So, I will explain what electricity is and how it works. To explain electricity, we must bypass the molecular level and into the atomic level. Atoms are the smallest unit of matter that form a chemical element. These are things that we cannot see with the human naked eye. Only a microscope can see things that are this small. To really understand electricity, we must look inside of an atom. This is where it gets kind of complicated, as the inside of an atom cannot be seen. Then, how do we know what the inside of an atom looks like? Well, we use this representation of the inside of an atom, which is called the Bohr model. Atoms consist of protons and neutrons, which form the nucleus of an atom. Orbiting the nucleus are the electrons. These electrons are the ones responsible for electricity. They are far lighter than protons in the nucleus, which, as you can imagine, makes them move around very easily. This is important because the movement of electrons is what forms an electric current. The atom's protons represent the positive charge of the nucleus, while the electrons represent the negative charge of the nucleus. These two charges will balance each other out within the atom, giving the atom a neutral charge. However, we can change the charge of an atom by causing it to either gain or lose electrons. For example, when there are fewer electrons than protons, it becomes positively charged because of the absence of electrons. But when there are more electrons than protons, it gets negatively charged. Now, you may be familiar with the term static electricity. If you don't, when you rub a balloon on your head, electrons move from the atoms inside your hair and get transferred onto the balloon, which in turn gains a negative charge. With the two opposite charges, they will both attract each other, something like a magnet. With that knowledge, I can explain what insulators and conductors are. Insulators are objects that have low electron mobility, and conductors are objects which have high electron mobility. An insulator is a material like plastic, while a conductor is a material like copper. See where I'm going with this? The millions of electrons within these wires can communicate easily, which creates an electrical circuit. An electric circuit is a path for transmitting electric current. An electric circuit includes a device that gives energy to the charged particles constituting the current, such as a battery or a generator, devices that use current such as lamps, electric motors, computers, and the wires or transmission lines. So you can see how this ties into networking. To conclude, electricity, or physics, is responsible for equipping the computers with power. Programming will tell the computer what to do from then and how to do it. Then, networking is used to connect the computers so that communication is possible all over the world.